Theorem 8.9 statement is the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. The meaning of the statement is like this. The midpoint of one side, so you take a midpoint of any one side, we'll take, let AB, midpoint of AB is E. E is midpoint of AB, so AE equal to EB. This is the first condition given. The second, see, line drawn parallel to another side, parallel. So through this point you draw a line parallel to another side means parallel to BC. And mark this point F. So what is given here, condition given here is E is midpoint of AB. So if E is midpoint of AB, then AE must be equal to EB, that is AE equal to EB. And also EF parallel to BC, it is given. And what is given? EF parallel to BC. So these two together we can mark it equation say 1. This is given. And to prove that F also bisects the third side AC. That means we are asked to prove AF is equal to FC. To prove F bisects the third side. Which third side? AC. F bisects third side AC. That means we are asked to prove AF is equal to FC. That is AF is equal to FC, we are asked to prove. Now, first we will do construction. We need construction. We will extend this line EF. We will extend it up to say a point D. And then we will draw a line CD parallel to AB. So what we did, we have extended. Extend EF up to D. This EF is extended up to D, and what we have done, we have drawn CD parallel AB, or we can say CD parallel BE. AB and EB are the same line. So if CD is parallel AB, then CD parallel EB also. Now we will take proof. In this quadrilateral, first BCDE. In quadrilateral BCDE. First we will prove that this quadrilateral is a parallelogram. We can easily prove. You see, first step you have BC parallel EF, or we can say BC parallel ED. BC parallel EF. BC parallel EF, it is given. BC parallel EF. So if BC parallel EF, we can say BC parallel ED also, because EF and ED are the same line. So this implies BC parallel ED. BC parallel ED. And EB parallel CD, or CD parallel EB. It is by construction. So what we got, you say, these two condition, what we got? In this quadrilateral, BCDE, you are getting BC parallel ED and CD parallel B. That means pair of opposite sides are parallel. So what does it imply? This implies that BCDE is a parallelogram, because pair of opposite sides are parallel. So it is a parallelogram, we have proved. Then if it is a parallelogram, then opposite sides must be equal. Then CD must be equal to BE. CD equal to BE. Opposite sides of, you will mention here opposite sides of parallelogram. So if CD equal to BE, this implies that CD also equal to AE. See, BE, this BE and AE are same. So if CD equal to BE, then CD also equal to AE. So this is what I have written. You can just mark it equation 2. Now we will take these two triangles and we will prove them they are congruent. I'll just mark this angle, say 1, this angle 2, this angle 3, this angle say 4. So we are taking this triangle and this triangle now, next step. So in triangle AEF and triangle CDF. So in this two triangle you see angle 1 equal to angle 4. Angle 1 equal to angle 4. They are alternate angles. Alternate angles. How alternate angles you see? I am just drawing here again. This DC line and AB line. This is DC and AB are parallel and AC is transversal. It is like this. This is the line AC. So this angle and this angle are equal. They are called alternate angles. So angle 1 equal to angle 4. Also angle 2 equal to angle 3. Angle 2 equal to angle 3. How? Also alternate angles. You will mention here alternate angles. How? You see angle 2 equal to angle 3. Same DC line parallel to AB line and ED is transversal. So this angle equal to this angle. That means angle 2 equal to angle 3. And you have already proved CD is equal to AE. CD equal to AE you have already proved in equation 2. CD is equal to AE. So what we are getting, you see, we are getting by side angles, angle side angle criteria. So therefore by angle side angle criteria, what we can say? We can say, or we can write here, therefore by angle side angle criteria, we can say these two triangles are congruent. That means triangle AEF congruent to triangle CDF by CPCT. You will mention here. And if the triangles are congruent, then what we can say? We can say AF is equal to AF equal to CF. This implies AF equal to CF by, this is by CPCT. This is by angle side angle criteria. Triangles are congruent and their corresponding sides are equal by CPCT. What does it mean? You see, we have proved AF equal to CF. That means F is midpoint of AC. This implies that AF is midpoint. F is midpoint of AC. That means F also bisects side AC of the triangle, and this is the complete proof. F also bisects. So the question was like this: ABC is a triangle in which E is midpoint of AB, EF is parallel to BC, and to prove F is also bisecting AC third side, that means to prove AF is equal to FC, and we have finally proved.